Hi, I'm Pat Kelly. Okay, in this problem, they give us vectors u and v. What they ask us for is a unit vector that is orthogonal to both u and v. So our vector as an answer is supposed to have two qualities. It's supposed to be a unit vector, and it's also supposed to be orthogonal to these two. And I'm going to start with that second thought, is if I'm looking for a vector that's orthogonal to both of these guys, a good place to start is the cross product. Cross product of two vectors, you know by now, I think, is a vector that's orthogonal to both of them. So let's get that. And I'm sure you've been doing quite a few of these as well in your homework, but your determinant form approach to this cross product calculation starts with I, J, and K across the top row. And the second row, I'm grabbing these components, 2, minus 3, and 4. And the bottom row, grab these components, 0, minus 1, 1. And then we get into cofactor expansion in order to find the cross product, find the result of this setup of ours. So I'm going to have across the top row, the I vector is going to multiply by the submatrix minus 3, 4, minus 1, 1. Then minus, and my J vector is going to multiply by the determinant of this submatrix, 2, 4, 0, and 1. And then finally, my K vector is going to multiply by the determinant of this submatrix, 2, minus 3, 0, minus 1. Okay, we're set up, ready to go. Now down below, I'll do my cross multiplying here, the crisscross pattern. So minus 3 times 1, subtract, looks like a negative 4, so we'll say plus 4 times the I vector, subtract. 2 times 1 is 2, subtract 4 times 0, which is 0. J vector plus crisscross negative 2 minus 0 times my K vector. And that'll clean up just a little bit to I minus 2J and then minus 2K. All right, very good. We have a vector that is orthogonal to the original two. But second half of the instructions for us, I mean, not literally second half, but they mentioned unit vector that is orthogonal. We got the orthogonality down, but in terms of it being a unit vector, that's not a unit vector. It doesn't have length 1. What we're going to do is normalize it. And the way we do that, come over here, is what we will need is the u cross v vector that we found, but then I need to find its magnitude. Right? So magnitude of that vector we just found, square root. First component is just 1, squared is 1, plus second component of negative 2, squared though is 4, plus third component there of minus 2, but squared is positive 4. Looks like they were nice to us because 4 plus 4 plus 1 is 9, and the square root of 9 is 3. Okay? And that tells me the length of that guy is 3, so what I'm going to do is divide that guy by 3, and that shrinks it down to length 1. Right? So it's going to be our last step here, but what we want is u cross v and divide that by the magnitude of u cross v. So my u cross v, just keep an eye on it right there. I'm really just dividing it by 3. Okay, so look at your components here, and all I will do is divide each component by 3. So minus 2/3 j minus 2/3 k And this vector will be normal, orthogonal to each of those, and normal in the sense that it's a unit vector length 1. Okay? All right, that's my answer. Hope that helps. Try some on your own.